Welcome. So today we're going to learn about how to factorise what's called a Monic quadratic equation. And we're going to use a process called splitting the middle term. Your textbook also talks about a process called a crisscross method. I don't use a crisscross method simply because splitting the middle term is just as easy and we can use it when we move on to non-monics. So the most important part of splitting the middle term is recognising what are the coefficients that we're working with. So we're not going to do this whole table, we're just going to do a few of them. So if I had 2x squared plus 7x plus 6, if we look at in front of our x squared, that's where we're getting our a value. It doesn't matter if these are changed order at all, our a value is always in front of the x squared. So 2x squared, our a value is 2. Our b value is in front of our x, so it's 7. And our c value is 6. And our next example, we have x squared. So we have one lot of x squared, so our a value is 1. Our b value is -4. And that's key. The minus is part of that coefficient. And finally our c, same deal, -5. Our next example, we've got x squared. So once again we have 1 plus x, so we have one lot of x. So 1 minus 30. Hopefully we get the idea. So why does this become important? So if we go back to how we did our binomial expansions, if I've got x plus alpha, x plus beta, and either could be a positive or a negative number, but positive is our default that we're using. If I was to expand this, I'd have x squared plus beta x plus alpha x plus alpha beta. Or I could factorise this down and say, well, x squared plus, we'll do it the other way, we'll say alpha plus beta x plus alpha beta. So if I knew what these two numbers are, I could directly factorise. So my last term, so my c value is the multiplication of two numbers. And my b value is the addition of those same two numbers. Now that may sound a little bit crazy, but watch you get into an example of how this works. So in my example here, I've got x squared plus 11x plus 18. So my a is 1, my b is 11, and my c is 18. So the idea is I need to find two numbers that multiply to 18 and add to 11. So I would normally write this down as I go, well, and we actually, to help us out for later on, we actually multiply our first digit, so our a by c. And this will just make it a bit easier if we get in this habit now. So we say, well, ac equals 18, and adding to b equals 11. So what numbers multiply to 18? We have 1 times 18, but if I add them together, I get 19, which is not going to work. What if I have 2 times 9? If I add them together, I get to 11. Awesome. So I know that 2 and 9 will multiply to 18. They'll add to 11. So I can actually factorise this term directly by saying, well, this is going to be x plus 2 x plus 9. And we're going to prove that in 1 second. So I'm just going to get rid of some of this writing. And the process of splitting the middle term actually means that we actually do need to split this term. So when we find these two numbers, 2 and 9, we split this 11. So we have x squared plus 2x plus 9x plus 18. And it doesn't matter which order you put these in so long as our numbers are correct. So then now we factorise each side. So factorising our x squared and our 2x, well, the only common factor is x. So we're going to factorise our x, we're left with x plus 2. On this side, I've got a common factor of 9. So if I factorise out the 9, I'm left with x plus 2. Magical. So now I've got two terms here with a common factor of x plus 2. I can bring that x plus 2 out the front. And then if I take this x plus 2 out, I'm left with x, and I'm left with plus 9. So I got to that same place that I got to down here of saying, well, x plus 2 times x plus 9 by splitting this middle term by just recognising I needed two numbers that added to 18, so multiplied to 18 and added to 10. Now say this method of going straight from recognising the numbers down to the factorised form only works when this a value is 1. And that's why this is called a monic quadratic equation, because the squared value is 1. Let's try another one. So this time we've got x squared minus 11x plus 18. So my a value is 1. My b value is negative 11. My c value is 18. So I'm looking for an AC, so 1 times 18 is 18, and we've got to add to minus 11. So notice we've got the same number here, this minus 11, but it's a negative. So we know that 2 times 9 equals 18, but when I add 2 and 9 together, I'm going to get to positive 11. But if I want to add to a negative number, it means I've got to have at least one negative number. If I'm multiplying to a negative number, I actually need to have two negative numbers. So negative 2 times negative 9 is still going to give me minus 18. Negative 2 plus negative 9 is going to give me my minus 11. So from this point, I can factorise directly to x minus 2, x minus 9, because my a value is 1. Once again, we'll prove it out. So we've got x squared minus 2x minus 9x plus 18. So we've split this negative 11 into negative 2 and negative 9. Factorise out my x. Factorise out here negative 9. So if I factorise it, I'm left with 8 x minus 2. The keynote here is I did factorise a negative 9 because I want to get the negative 2 in those brackets. Now I can bring out my x minus 2 out the front, and I'm left with x minus 9. Okie doke, looking at our next one. So we've got an a value equals 1, a b value equals 6, c value equals 8. So we AC equals 1 times 8, and adding to 6. So factors of 8. We've got 1 and 8. That's going to give us 9. No dice. 2 times 4, yep, gives us 6. So we've got x